Hello class, welcome back. This will be the third and final video for network parameters. Now before, we set I2 equal to 0 so that we can calculate Z11 and Z21. Now we're going to set I1 equal to 0 so we can calculate Z12 and Z22. But we already have the value for Z12, so really the only thing we need to calculate is Z22. If we set I1 equal to 0, for all practical purposes, this resistor is canceled, at least from the perspective of V2. V2 will only have to deal with this resistor and this resistor in series, because there's no current coming through the first resistor. We also know that because that resistor has no current in it, the voltage drop across V1 will be the exact same value as the voltage drop across 56.25, which we know will end up giving you the same value as Z21 as before. So that means we only have to calculate Z22. Z22, after we set I1 equal to 0, will become V2 over I2, as seen from the right side, looking back to the left. We can assume that V2 is the source. If we assume V2 is the source, then I2 would also be the source, and that basically is V total over I total, which is Z total. Since they've given us the value for the two resistors, we don't have to do any mathematical work over here with voltage and current. We simply can just add these values together because they will be in series. Why would they be in series? Simply because the only two components that has current from V2 will be the 200 ohm resistor and the 56 ohm resistor, because we said that I1 we assume is equal to 0. So once again, we simply just add these two resistors together, and that will give us our final value of 256.25. And we can kind of see that from the very beginning because this is like a balanced T network. So we can literally guess the answer if we recognize that these is a T network and it is balanced. Okay. All right. So putting everything together, the final values for Z1 for your network parameters, well, let's do it in the proper way. The final solution for your network parameters would be that V1 is equal to 256.25 times I1 plus, what do we get value for here? Let's go back and look. 56.25. 56.25 times I2, and V2 will be like almost like a mirror. 56.25 times I1 plus 256.25 times I2. Now this is an exact mirror because these two resistors here from both inputs are the same, but on the exam they could be different, so you may not have this exact mirror between the Z11 and the Z22. However, if this is a resistive network, there will be a mirror between Z12 and Z21. These two numbers should be the same if it's a resistive network. I hope this helps, and good luck on your exam. Thank you.